am Priti Patidar at Index Institute of Pharmacy, Malvanchal University, Indore. Today's topic is Introduction to Organic Chemistry. Organic chemistry is the study of compounds of carbon. It means we study about the compounds of carbon in organic chemistry. The organic compound is any chemical substance that contains carbon, hydrogen and oxygen. It means inorganic compound contain mainly the carbon, hydrogen and oxygen, and other compounds may include fluorine, chlorine, bromine, nitrogen, sulfur, phosphorus and etc. Now, classification of organic compounds. Organic compound is divided into two types: open chain or aliphatic compound and cyclic compound. Cyclic compound is further divided into two types: homocyclic compound and heterocyclic compound. And homocyclic compound is further divided into two types: alicyclic compounds and aromatic compounds. Now, open chain or cyclic or aliphatic compounds. Carbon atoms are linked to each other either in linear or branch manner. For example, propane CH3 single bond CH2 single bond CH3, and butane CH3 single bond CH2 single bond CH2 single bond CH3. Now, closed chain or cyclic compound. These compounds have closed chain of atoms. They are of two types: homocyclic or carbocyclic compound and heterocyclic compound. Now, homocyclic compound. The ring structure is made up of only carbon atom. They are of two types: aromatic compounds and alicyclic compounds. Aromatic compounds and benzoate compounds. Compound contains one or more benzene rings in their structure. They have pleasant odor. For example, monocyclic aromatic ring like benzene and polycyclic aromatic ring like naphthalene. Now, alicyclic compound. Alicyclic compounds with ring structure containing only one carbon atom. They behave like aliphatic compounds. For example, cyclopropane, cyclobutane and cyclopentane. Now, heterocyclic compounds or non-benzoate compounds. Cyclic compounds in which the ring atoms are made up of heteroatoms like nitrogen, oxygen and sulfur in addition to carbon. For example, pyrrole, furane, pyridine, thiophene. The heterocyclic compound is divided into three parts: monocyclic, bicyclic and polycyclic, which means 3-membered, 4-membered, 5-membered and 6-membered. Now, monocyclic heterocyclic compounds. 3-membered rings. These rings have 2 carbon atoms and 1 heteroatom. For example, oxene, oxetane. 4-membered rings. These rings have 3 carbon atoms and 1 heteroatom. Like rings are less stable due to strain. For example, oxetane. Now, 5-membered rings. These rings have 4 carbon atoms and 1 heteroatom. For example, furane and pyrrole. Now, 6-membered rings. These rings have 5 carbon atoms and 1 heteroatom. For example, pyrene, thiopyrene, pyridine, etc. Now, bicyclic heterocyclic compounds. These rings contain 2 ring system in which at least one ring contain heteroatom. For example, andol, isoquinoline and quinoline. Now, Polycyclic heterocyclic compounds. This rings contains more than two ring system in which at least one ring contain heteroatom. For example, aspiridine. Now, IUPAC system of nomenclature of organic compound. Common name. The common name of a compound is one which has history behind and is accepted on amount of its long uses. Systematic name. The systematic name of a compound is based on its structure. IUPAC, which is commonly referred to the International Union of Pure and Applied Chemistry, system of nomenclature. It was published in 1957 and released in 1967. IUPAC rules for assigning name to complex molecule. First, name for branch chain hydrocarbon, and second is name for other classes of compounds. Now, naming of branch chain hydrocarbon. Rule 1. Select the longest continuous carbon chain in the molecule, which need to not necessarily have to be horizontal straight. This is called a parent chain or a main chain, while other chain attached to it are referred to as side chain. The number of carbon atom consisting the main chain determine the parent name of hydrocarbon. For example, these two chains, longest chain in the horizontal form and longest chain in the zigzag form. As in both the cases, longest chain contains 6 carbon atom, therefore the parent name of hydrocarbon is hexane. In case a molecule contains 2 carbon chain of the same length, the one that carries larger number of branches is designated as parent chain. Like first is in the one branch only, and this is in the 3 branches. Both structure contains 6 carbon in long chain, but second shows 3 branches attached to parent chain. Therefore, the chain shown in second is selected as the parent chain. Rule second. Number the carbon atom of the parent chain is 1, 2, 3, 4, etc. Starting for the end that give the smallest possible number to the carbon carrying the substituents of branches. In the case there are 2 or more substituent present on the parent chain, 2 set of locands are obtained according to as the numbering is done from the left or right. Rule 3. Prefix the name of the substituent to the name of the parent hydrocarbon and indicate its position on the main chain by writing before it the locant. A hyphen is inserted between the locant and the substituent name. The exact name of the substituent methyl group CH3 is written as the 3-methyl. Rule 4. The complete name of the hydrocarbon is written as one word, hence the hydrocarbon. Name of the compound 3-methyl hexane. In case a number of substituents are present on the main chain, their names are prefixed to the name of the parent hydrocarbon in alphabetical order, inserting hyphen in between the name of the Substituent. Name of compound 3-ethyl 2-methylhexane. Rule 5. If the same substituent is present two or more times, this is indicated by prefix di, tri, tetra, etc. To the substituent name, the locants of individual substituents are set off from each other by commas and separated from the written name by hyphen. The name of the substituent are written in alphabetical order regardless of multiplying prefix, di, trio, and etc. Thus, ethyl comes before methyl in the name of the following compound, the prefix di being neglected for the purpose. 3 di diethyl 4 dimethyl heptane. Rule 6. In case the substituent on the parent chain is a complex one containing more than 4 carbon atoms, it is named as substituted alkyl group. Containing more than 4 carbon atoms, it is named as a substituted alkyl group, whose carbon chain is named from the carbon atom attached to the main chain. The name of the complex substituent is given in brackets to avoid confusion with the number of the parent chain. Name of compound 5,1,2 dimethyl propyl nonane. Rule 7. The position of a double or triple bond in alkenes or alkynes is indicated by prefixing the number of the carbon preceding such as a bond. The carbon chain being numbered from the end, which assigns lower position number to the double or triple bond. CH3 single bond CH double bond CH single bond CH2 single bond CH3. Names of other classes of compounds. Other classes of compounds like alcohol, aldehydes, ketones, carboxylic acids, etc. The compounds belonging to these classes are called functional compounds. Monofunctional compounds are that compounds containing one functional group are referred to as monofunctional. These are named as derivatives of the parent hydrocarbon by the following rules. Rule 1. Select the longest carbon chain bearing the functional group. This is the parent chain and is numbered from the end that gives lower positional number to the functional group. Rule 2. Write the name of the parent hydrocarbon and prefix the substituent names. Rule 3. Drop the terminate E of the hydrocarbon name and add the suffix assigned to the functional group present. Rule 4. Insert the positional number of the functional group separated by the hyphen or either side before the name of the parent hydrocarbon. Rule 5. Halo and nitro compounds are always named as substituted hydrocarbons like 3,4-dimethyl 1-hexanol, 3-methyl 1-pentenyl, 3-pentane 2,1. Polyfunctional compounds. The organic compound which contain two or more different functional groups in the same molecule are called polyfunctional compounds. Rule 1. When there are many functional groups present in a molecule, only one suffix can be used to form a systematic name. The group name named as suffix is termed the principal group. For example, 3-hydroxy 1-butanoic acid. Rule 2, group suffix name and prefix. Like C double bond OH, carboxylic acid. It's a suffix name and the prefix is carboxy. Like 2-bromo 4-hydroxyl 1-ethanol and 4-amino 2-hexanol and 3-amino 4-pentane 1L. Now structural isomerism. Isomerizers are molecules that have the same molecular formula but different from each other in physical or chemical properties, and the phenomenon is called the isomerism. इट्स मीन्स आइसोमेरिज मॉलिक्यूल्स जो होते हैं वो सेम मॉलिक्यूलर फार्मूला कंटेन करते हैं बट दे आर डिफरेंट इन अ फिजिकल और केमिकल प्रॉपर्टीज़, और इसी को आइसोमेरिज्म बोलते हैं. Bodily isomerism is of the two types, structure isomerism and stereoisomerism. First, structure isomerism. When the isomerism is simply due to difference in the arrangement of atom within the molecule without any reference to space, the phenomenon is termed as structural isomerism. Second, stereoisomerism. When isomerism is caused by the different arrangement of atom or group in space, the phenomenon is called stereoisomerism. The stereoisomers have the same structure formula but different in the stellar arrangement of atom or group in the molecule. Now, classification of isomerism. Isomerism is classified into two types, structure isomerism and stereoisomerism. Structure isomerism is further divided into chain isomerism, ring chain isomerism, positional isomerism, functional isomerism, metamerism, and duotomerism. And stereoisomerism is divided into two types, geometrical isomerism and optical isomerism. Now, chain or nuclear isomerism. This type of isomerism arises from the difference in the structure of the carbon chain which form the nucleus of the molecule. It is therefore named as chain or nuclear isomerism. For example, N-butane and isobutane, CH3 single bond CH2 single bond CH2 single bond CH3. Molecular formula is C4H10. Now, positional isomerism. When two or more compounds have structure formulas which differ only in the position of the substituent atoms or group on the carbon chain, these are called the position isomerism. And the phenomena is termed positional isomerism. For example, N-propyl alcohol and isopropyl alcohol. CH3, single bond CH, single bond OH and single bond CH3. Its formula is molecular formula C3H7 and OH. Now, functional isomerism. When any two compounds have the same molecular formula but possess different functional groups, They are called functional isomerism, and phenomena is termed functional isomerism. For example, diethyl ether and butyl alcohol. Its molecular formula is C4H10O, and acetone and acetaldehyde. Its molecular formula is C6H6O. Now, metamerism. The isomerism caused due to the unequal distribution of carbon atoms on either side of the functional group in the molecule of compounds belonging to the same class is called metamerism. For example, methyl propyl ether and diethyl ethyl ether. Its molecular formula C4H10O. Thank you.